Hey, hi. So, before I start, we'll see how this works. This is the first time I've done this recording in Windows 11, and hopefully it all turns out okay. Today, I'm going to be doing convolution in continuous time. Last time we did convolution in discrete time, and you remember we had that sigma notation involved with it. So today we're going to be doing continuous time. And just a reminder, I'm also right now recording from my home, and I have kind of limited desk space, so I'll be shuffling around a lot you don't get to see, but hopefully this will work out. So, y of t equals integral negative infinity to infinity of x of tau h of t minus tau d tau. This tablet thing is interesting in Windows 11. We'll make it work. So forgive my bad writing. That's we've seen this before last week some point. That is the convolution integral. I want to jump right into an example. So I'll start with example 2.6. If you are looking at the book, by the way, section 2.2 is this, the convolution integral. It starts out like deriving this, and we're skipping deriving it. We're just going right into an example. If you're curious how it got that way, you can look into it. It spends like 6 or 7 pages deriving it. Okay, so example 2.6. See, it's occasionally drawing these extra lines. I don't mean for it to draw, but we'll work with it. So it gives me the following signal. X of t equals e to the negative at u of t. E to the negative, where's that alpha? That's a. Negative a t u of t. Again, please forgive my handwriting. Where a is positive. And the impulse response, h of t, we're given is just u of t. So here's what we want to do. First things first, let me go ahead and draw x of t. So there's t, e to the negative at, where a is a positive number. That will be 1 times 0. And it will look like this. Asymptote, not actually touching. Now for h of t minus tau, well, h of t itself, u of t, that's the step function. That's 1. So this is h of t. T. Here's x of t. And actually, I want to write that as, grab the eraser, because I really want to do this as x of tau. And the only real difference is that's of tau. Oh, what happened there? There we go. Tau. Okay. So, but I want h of t minus tau, which t minus tau, variable being tau, we're going to flip this left to right. And there's going to be 2 different ways this can look. So case 1, it's going to look like this. Height is still 1. Here's tau. If t, case 1 is t less than 0. This is h of t minus tau. And forgive me kind of traveling all around the screen. I'm trying to make use of space before I have to extend it. Second case, case 2, is t greater than or equal to 0. That is, wow, I'm trying to draw a horizontal line and it's doing that. 0, tau, t, 0, height 1. Wow. My tablet pen is just jumping all over. Well, hopefully you get the gist. So one thing to notice, this first case here, let me switch colors for a second. So this case here, compare this one to x of tau. There is no overlap because x of tau only exists for positive tau. This only exists for negative tau. There's no overlap, which means that if you multiply it here, then it's 0. For case 2, x starts at 0 and it keeps going infinitely to the right, but that means the only overlap is right here between 0 and t. So if tau is between 0 and t, for t greater than 0 or equal to 0, then you can do that multiply. If not, you're multiplying by 0 right here. Okay, I'm going to try to make a larger window. Okay. Okay. Now, that means that this, where's my mouse cursor? This part here, the x of tau, h of t minus tau, is 0 only for positive t. Well, positive or 0t. And it's also, or sorry, it's non-zero only for positive t. And it's also non-zero only when tau is between 0 and t. And the multiply, if tau is between 0 and t, then we have this equation, this, which is e to the negative at times 1. So let me scroll down. Go back to black here. So that means we've got the x of tau, h of t minus tau is going to be e to the negative at when tau is between 0 and t, and 0 otherwise. This is for t greater than 0. So then for t greater than 0, greater than or equal to 0, we have y of t is the integral. It would be from negative infinity to infinity, but it ends up only actually being from 0 to t because it's 0 to the left, because this is 0 to the left, and it's 0 to the right. So the only intervals that matter, back to that, are from 0 to t of e to the negative a tau d tau. And that sure is a way easier thing to deal with. So the integral of e to the negative a tau is negative 1 over a e to the negative a tau from 0 to t. Scroll down some. If my mouse cursor is jumping all over because it doesn't like me having the tablet and can I do that? Let me make this a little bigger again. It doesn't like me having both the tablet and the mouse. Okay, let's try that again. View, zoom back to 100%. Okay. Where are you, cursor? There you are. Equals. Well, let's evaluate this integral. We can pull the negative 1 over a out because there's no variable there. Negative 1 over a times e to the negative a t from 0 to t. Negative 1 over a times, sorry, this is tau. Tau. E to the negative a t minus e to the 0. Negative 1 over a times e to the minus a t minus 1. And to make it look a little neater, we can pull the negative inside. Equals 1 over no, 1 minus e to the negative a t. That just looks nicer if it wasn't for the cursor jumping around. And also, for t less than 0, we already said earlier, y of t equals 0. Because of that, any function that exists only for t from 0 on, we can just say it's the step times the step function. So we can say our final answer here, that I lost my cursor again, y of t equals 1 over a times 1 minus e to the negative a t u of t. And that would be our final answer for that convolution. Blue. Blue is a nice color to circle it with. There. Okay. That would be our final answer for that convolution. Now, let me go on to the next example, example 2.7. By the way, as I'm getting my papers organized, just like before, I will be scanning my notes. I just won't be able to do that till I'm on campus on, hopefully we'll be able to get it on campus Wednesday. When I'm on campus Wednesday, I'll be able to see it. But as I do that, I'm gonna save this just in case. Signals and systems example 2.6. Okay, now I'm going to clear that. Of course, you guys have the video. You can pause it at any time. So example 2.7 says we've got the following signal. We've got an x of t is defined as 1 when t is between 0 and some, come on, give me a straight line, some big T, 0 otherwise. Which is a kind of step function. It's not the 0 to infinity type step function. I'll draw a picture of that in a moment, but let's write h of t it was behaving well for a while and now it's back to misbehaving, is t for 0 less than t less than 2. That's 2, come on. It'll let me write a 2 eventually. 2, big T, and 0 otherwise. Okay. So let's go ahead and draw this. Where are you, cursor? Down there. So x of t is pretty easy. Drawing a straight line is not easy. This tablet, by the way, that I'm using right now, I've had this since COVID. It seems to maybe have gotten close to the edge of its life. What is with that? I don't know why it keeps doing the heartbeat thing. Maybe I'll just try doing straight line with writing equations. I have to use that, but straight line thing I'll write with my mouse. Okay. So there's 0. This is tau. Height of 1. This is big T, and then this is x of tau. Now, we changed variables from t to tau because we're going to do convolution. We need to do it with tau. And let's draw the standard h before we start doing stuff. For a moment, gotta make sure I check something here. So h of t is t. I won't just draw h. I'll do h of t minus tau for right out. So is t, which is a line going this way, which means when I do t minus tau, it'll be a line going this way. So we've actually got a few cases. So case 1. Case 1 is for t less than 0. Well, actually, before I do that, I don't want to skip this part, just to show you how I'm doing this. So just straight up first, h of tau, not t minus tau, h of tau. 2t. It looks like that. Slope of 1. This height is then 2t. When we flip it left-right to do t minus tau, its height is the same and its width is the same. So it should still be 2t wide and 2t tall. So now for the case of t less than 0. Here's 0. Here's tau. Here's t. The triangle should be and this is going to be h of t minus tau. T minus tau, so we're flipping it left to right, and it's going to go this way. Height is still 2t, and the width of this is 2t, so that means that this has got to be 2 big T, minus 2 big T. There's that case. Next case. So our cases are going to depend on this triangle. Remember, for convolution, we're taking this triangle and we're passing it over. I don't actually know if you can see my cursor. We're taking this triangle and we're passing it over the x, which means our different cases are going to be how that triangle interacts with that x. So we definitely want t greater than 0. And let's talk about the upper limit. So the triangle that we've already drawn is going to be that way with no overlap with the rectangle up until the point hits 0. From when the point hits 0, the triangle is going to go towards the right. Let me kind of imagine this. So you'll have a triangle like this. It's going to go to the right. It's going to go to the right. It's going to keep acting that way until it hits here, because once it passes over, where they cross is going to be a different shape. So our second interval then is going to be t from 0 to big T, where this is big T, here's t, height of 2t, and it's going to go like this. And this is still t minus 2t. How do we know that's going to be to the left of 0? Because it doesn't matter what t is. If little t is less than big T, and we subtract 2 big T's from this, we'll subtract, it's already less than t, so it's got to be negative. So it's going to be that shape. Because little t is left of big T, and if we move 2 more big T's left, we're going to pass 0. So that's the case 2. Next case, we've got that triangle up until the triangle hits basically this. Or when it's like this and it crosses over. Up until it no longer crosses that rectangle at all. So now is the case for little t is greater than big T. So the front end of the triangle is now past the rectangle, but the back end of the triangle is still in the rectangle. So until the back end of the triangle is touching the edge of the rectangle. So how do we calculate that? So we want right here, it's going to happen where t minus 2t equals t. That's where the back end of the triangle is going to hit the end of the rectangle here. You add 2t to both sides. And it happens when t equals, sorry, wait a minute. I want to make sure I'm not messing that up. Oh wait, no, not yet. I'm skipping ahead. Sorry, just checking my notes. Skipping ahead. I want to keep going until the back of the triangle here is here, because the triangle is 2t wide. It is wider than the rectangle. So now we want to talk about this triangle, where the point is past big T, but the back of the triangle has not crossed over yet. So the point of the triangle is past the end of the rectangle, but the back of the triangle is not yet. So let's visualize this tau. Let's say this is big T. Little t is over here. Height is still 2t. My slopes are going to get weird, but t minus 2t is over here now. Boom. Boom. Mainly, you want to look at the interaction between the triangle and t. Let me put big T over here. Triangle and where the rectangle is. The rectangle starts at 0 and ends at big T. So this first case, the triangle has not reached 0 yet. This second case, the triangle has reached 0 but has not reached big T yet. The third case, the point of the triangle has passed big T, but the back of the triangle has not reached 0 yet. Now our fourth case is going to be where the back of the triangle has now passed 0. Still height of 2t. Big T is here. So now we want t also, I didn't rewrite them all. These are all h of t minus taus. Let me can I no, I don't want to do that. Selection. No. Copy. No, let me copy. I'll leave it as is. Those are h of t minus taus. Oh, go back to my brush. This is an h of t minus tau, h of t minus tau. This is again going to be an h of t minus tau. So now little t is past big T. And t, little t minus 2 of big T is past 0. Horrible to scale, but hopefully this makes sense. So this triangle now, the point of the triangle is past the rectangle. The back of the triangle is now past 0. So that's going to keep going until the back of the triangle hits the edge of the rectangle, which is this here, which is when t is 3t. Add 2t to both sides. 3t. And then in case 4, the triangle is now completely past that rectangle. There's t, little t, t minus 2 big T, height of 2t, let's get that better this way. There we go. So this is t greater than 3t for h of t minus tau. Okay. We've got 5 cases, but fortunately, it's going to be not too bad because this is all rectangles and triangles. This is an integral because integral is area under a curve, we can do this geometrically. Let's do it in green. No, let's do it in purple. Why not? So we're going to start out with the first case. Case 1, where t is less than 0. That's this one right here. There's no crossover with the rectangle. So if there's no crossover, that means that in those places, y of t is equal to 0. Also, where there's no crossover is that last one we did up here. When little t is greater than 3t, because now the triangle is completely past the rectangle. Again, there's no crossover. So t equals 0 and t greater than 3t, y of t is equal to 0. Those cases. Now let's look at this case where little t is between 0 and big T. So little t is between 0 and big T. Let's draw this. I'll draw the axes here. Here's tau. Here is big T. Little t is between those. And if we draw that part here, the triangle has a slope of -1. So if this distance is little t, that means this distance is also little t. And the rectangle is height 1. So you multiply the triangle times the rectangle, you're multiplying by 1. The rectangle basically only defines the shape. So it's the area under this curve is the integral. Oh, this area down here. Where this is a graph of x of tau, h of t minus tau. Okay, so area of a triangle, we can do this geometrically, is 1/2 times the base, t, times the height, t. So for this case, y of t equals 1/2 t squared. This is really weird drawing this with a mouse, but hopefully it works. Okay, that's that case done. Next case. We have little t is between big T and 2 times big T. Which is this one up here. The point of the triangle is past the end of the rectangle, which means, let me draw the axes here. Here's tau. There's big T. The point of the triangle is past it. Now try to imagine, let me do this yellow. We overlay that rectangle. Right here. Only that width. So we have this part here, this vertical line here to make this rectangle, and then this triangle up on top of it. So let me go ahead and draw that. So here we have a certain height, and then the side of the triangle. Okay, so, but what is that height? Well, this is t, then this is t. Sorry, that's not t. Here is t over here. But t is over there. For this case, t is to the right. The slope is -1, which means this height is t. So if the slope is -1, this height is t. If we go over t more here, we would go down t more. So t minus tau. Not tau, sorry. T minus big T. Because the slope is -1, so we go to the right big T, we go down big T. So we've got two pieces here. We've got the triangle, which is 1/2 times the base, which is big T, times the height, which is little t. Nope, not little t, sorry. The height of this triangle is little t minus little t minus big T. And then the rectangle, which is base is big T, and the height is little t minus big T. Okay, we can multiply that through. And we get 1/2 big T times little t minus little t is 0. Negative t is big T. Big T plus big T times little t minus big T. 1/2 big T squared plus big T little t minus big T squared. So y of t there is big T little t minus 1/2 big T squared. Whoops, that's not what I want to do. Where's my cursor? That's that case done. One more case because we already did the final case. So we need the case where t is between 2t and 3t. Hang on a moment. I will do that over here. So now t is between 2t and 3t. So now we have the same shape, but we're shifted more to the right. Whoa. Sorry, some weird pop-up just came up. My antivirus. It was done with its scan for the day because it just hit midnight here. If you're curious about what time I'm recording this, this is Monday night. Here's tau. Here's big T. Here is t minus 2 big T. Let's look at the heights here. Pretend that's a straight line. Okay. So this height here is 2 big T. And this height is t minus big T. It's the same rectangle as in the previous one. That's why the height is little t minus big T. And the reason why the height here is 2t is because that's the maximum height of the back of the triangle. So this is where the back of the triangle ends. And the front of the triangle is cut off because it's past the big T. So we've got y of t. Again, we've got a rectangle and a triangle. triangle, 1/2 times the base, which is big T minus little t minus 2 big T, times the height of the triangle, or the height of the triangle, whoops, is times 2 big T minus little t minus big T. That's from here to here. Then plus the rectangle. Base is big T minus little t minus 2 big T times the height, which is little t minus big T. And that looks way more complicated than it is, but we'll just simplify this out one step at a time. Inside this parentheses, we've got big T minus negative 2 big T. So that is 3 big T minus little t times this thing is 2 big T minus negative big T, so 3 big T minus little t. Plus big T minus 2 big T, again 3 big T minus little t times little t minus big T. And then we FOIL everything. 1/2 times 9 big T squared minus 6 big T little t plus little t squared. So we're just foiling there. And then we FOIL the below one, which gives us 3 big T little t minus 3 big T squared minus little t squared plus big T little t. We put that 1/2 through. My mouse hand's getting tired here. 9/2 big T squared minus 3 big T little t plus 1/2 little t squared plus 3 big T little t minus 3 big T squared minus t squared plus big T little t. And all that equals minus 1/2 little t squared plus 1 big T little t plus 3/2 big T squared. Now we just take everything together. One moment. Let's get a little more space again. I'm probably not going to show you or give you this exact board file because you guys are able to write it. But I'm going to be giving you my handwritten notes when I'm able to scan them. End result. Y of t equals case 1, 0 for t less than 0. This is not going to be neat on this. I'm sorry. It's way neater on my handwritten ones that you'll get. 1/2 t squared for the next case. 1/2 t squared for t from 0 to big T. 0 less than t less than big T. Between big T and 2 big T, we've got this. Big T, little t. Checking my notes really quick for something. Yeah, okay. Sorry, I had to turn over a page of my notes. 1/2 big T squared. This is for little t between big T and 2 big T. Then between 2 big T and 3 big T is this one right here. Minus 1/2 little t squared plus big T little t plus 3/2 big T squared. This is for little t between 2 big T and 3 big T. And then 0 for t greater than 3 big T. That's a lot of work. It would have been less work by hand than by mouse, but hopefully you guys get the gist for that. Go back through it if you have to. Draw yourself. The most important part is setting up the different intervals of the interactions between I'll grab a green, between this shape as it slides over and this rectangle. So we need the interactions there. Okay. I'm going to check something quick. How long have I been recording for so far? Does it say? Oh, what? It didn't record? It's set to streaming for some reason. Okay, I'll figure something out later. I'm gonna keep going there. I don't know why it's streaming instead of recording, but I will figure out where it's streaming to. It's been 48 minutes. I've got one more example to go. Don't save. Actually, I'm going to pause this right now and figure out what's going on.